Hello, Professor. Good morning. This is Venkateshwar Vejalla. Now I am going to explain about assignment summit which you assigned this week. This is a non-programming assignment. In this assignment, you given four questions which are a hash table that hashes all values to the same slot is essentially equivalent to what other data structures. Like analyze the hashing functions that were discussed in the lecture slides which that means which you previously said in the class, elaborate on the benefits and drawbacks of each function, and analyze the two methods for resolving collisions in hash tables that were discussed in the previous class, elaborate on the benefits and drawbacks of the each method, and what strategies and issues should you consider when you are resizing a hash table, and what are the likely complications and how would you address them. After going to the assignment, this is a non-programming assignment as you said earlier, and here these are the answers for the questions which you assigned me. The first one is the equivalent of an array where each element is stored at its own index is a hash table that hashes all values to the same slot, which means which shows the hash table that hashes all values to the same slot is essentially equivalent. And here analyze the hashing function that were discussed in the lecture slides, elaborate on the benefits and drawbacks of the each function, which means the modulo function, which the multiplication method and universal hashing are among the hashing functions covered in the course slides. The modulo function divides the key by the hash table size and returns the resulting amount as the index. That means this function has the advantage of being quick to computate and easy to implement if the hash table size is not prime or not proportionally prime to the key, where the key is multiplied by a constant value between 0 and 1 using this hashing function, which then takes the fractional portion of the product and multiplies it by the size of the hash table to produce the index, which means the constant value must be carefully chosen and it is more computationally expensive. By using this function, a random hash function from the family of hash functions is chosen and it is then applied to the key to produce the index, where this function has the advantage of having a good distribution and being very resistant to clustering and collisions of the hashing function, and the random function selection, however, involves more work and could have higher memory overhead. Where and we came to third question. You said that analyze the two methods of for resolving collisions in hash tables that were discussed in the lecture slides. And we're getting to the point. Chaining and opening address are the two techniques for resolving collisions in hash tables that were covered in the previous class. Where chaining means chaining includes keeping all colliding elements in a linked list of the same index. This approach has the advantage of being easy to develop, being able to handle any amount of collisions, and performing well even there are few collisions. However, because pointers are used, it may perform poorly with catchy and may operate slowly where there are lot of collisions. Which means if we have a lot of collisions, it operates slowly and gently and it performs poorly with catches. After that, finding a different index to store the colliding element is a process used in open addressing technique like linear probing and or quadratic probing can be used for this, which means these two, linear probing and quadratic probing, are used to address the process to store the colliding element, which this approach has the advantage of being able to manage melee collisions and having superior catchy performance than chaining, which means compared to chaining, these collisions have superior catchy performance when we compare to chaining, and the load factor is large or the table is almost full. It is performly and calls for careful consideration while choosing the probing strategy. What strategies are used should you consider when you resizing a hash table, and what are the likely complications? How would you address them? A hash table load factor and collision risk should be taken into account while enlarging it. To prevent performance degradation, the load factor and where the ratio of the number of entries to the size of the hash table should be kept and the below of the predetermined level, which means that strategies and issues of this resizing hash table are more likely complications. And a newly larger table is made and all of the items are rehashed and added to it in order to resize a hash table. And the potential drawbacks include higher memory utilization and poorer performance, which shows that and if you have any collision occur, the process of the hashing should reduce to higher memory utilization and gives poorer performance. It is advised to utilize a gradual resizing strategy where the new table size is increased rather than doubling at all at once. Which means if we use different strategy, doubling all at once is the gradual resizing strategy utilized to be advised. To ensure optimum speed and key distribution, it is also crucial to use a solid collision resolution technique and hashing functions. Thank you, Professor.